Welcome back to the MATLAB tutorial series. Today, we're diving into one of the most important skills in MATLAB, graphing and visualization. By the end of this lesson, you'll know how to plot simple functions, customize graphs, combine multiple plots, and we'll finish with a stunning animated visualization.
Let's start with the basics. Plotting a simple function. First, we create a vector of x values and then compute y equals sine of x. Using the command plot xy, MATLAB immediately displays a line graph. This is the foundation for almost every type of visualization you'll create.
Now let's make this plot more readable and more beautiful. We can customize the line color, thickness, and style using plot x, y, r, line width, 2. We can also add labels and a title. X label, x, y label, sine x, title, sine wave. And if we want grid lines for clarity, we simply type grid on. These small enhancements dramatically improve the professionalism of your plots. Next, let's plot more than one function on the same axes. We can graph both sine x and cosine x together using plot parenthesis x, y1, hold on, plot parenthesis x, y2, hold off. Or even better, use MATLAB's built-in legend, legend parenthesis sine of x, cosine of x. This is perfect for comparison, analysis, and presentation quality visuals. Sometimes you want multiple graphs, but not on top of each other. That's where subplots come in. We type subplot 2, 1, 1 to place a plot in the top half of a 2-row layout. Then subplot 2, 1, 2 for the bottom half. Subplots make it easy to show related data side by side in a clean and organized layout. Now let's move into something more exciting, 3D visualizations. To create a 3D surface, we first need a grid of x and y values. We do this using MATLAB's mesh grid function. Mesh grid creates two 2D arrays that represent all combinations of x and y. Think of it as turning two simple vectors into a full coordinate grid. Once we have the grid, we compute a z value at each point. For example, z equals sine of x squared plus y squared. Now we can plot the result using surf x, y, z. This creates a fully colored 3D surface where height is represented by color and shape. To make the visualization smoother and more appealing, we add shading interp command, which blends colors smoothly across the surface. Color map turbo command, which means a vibrant color palette that highlights shape. And color bar command that shows how colors map to the z values. We can also rotate the figure with the mouse to explore it interactively. This type of 3D surface is incredibly useful for engineering models, optimization tasks, potential fields, and anywhere you need to visualize a function of two variables. To finish the video, let's create something truly eye-catching, a 3D animation where the surface changes shape over time. We'll start with the same ripple-shaped surface, z equals sine of x squared plus y squared. But to make it come alive, we add a time-dependent term. Z equals sine of x squared plus y squared plus t. As t changes, the peaks and valleys move across the surface, creating a smooth wave motion. To animate this, we place the surface plot inside a loop. Each loop step increases the time variable t. We recompute z using the new value of t. MATLAB redraws the surface using surf. Draw Now tells MATLAB to update the graphics window immediately. This combination produces a fluid animation, almost like ripples expanding through water or an energy field pulsing outward. For visual stability, we keep the axis limits fixed so the camera doesn't shift. Combined with the shading and color map applied earlier, the result is a beautiful, dynamic visualization. Animations like this are fantastic for scientific demonstrations, dynamic system visualizations, classroom lectures, or even as impressive intros for MATLAB projects or YouTube videos. It's a perfect showcase of how MATLAB can turn mathematical formulas into living, breathing graphics.
In this video, we explored basic 2D plotting, customizing graphs with colors, labels, and grids, plotting multiple functions, using subplots for layout, creating 3D surfaces, and generating stunning animated visualizations. MATLAB is incredibly powerful for scientific visualization, and mastering these tools opens the door to better analysis, communication, and creativity. If you enjoyed this tutorial, remember to like, comment, and subscribe. Thanks for watching, and I'll see you in the next lesson.